Hello and welcome to our inaugural webcast type training for our HVAC product line. My name is Brian Musica. I'm the sales manager at Advanced Cooling Technologies and wanted to thank you for your participation. We were pretty excited about the amount of people that joined through the emailer, and also wanted to let everyone know if it isn't obvious that there is a chat box that you can type in any questions that you might have during the webcast, and we have kind of a crew standing by ready to answer any questions. And also, if there's any more detailed inquiries or questions that come up afterwards, feel free to reach out to your sales engineer and we'll make sure we provide you that information as well. Just wanted to come on and provide some basic background about kind of why we're doing this. So as most of you are aware, at the turn of the year, and we've kind of been transitioning from a single point of contact for our HVAC product line to a more distributed, geographically located business model. And the main reason for that is we want to be able to come out and see you guys more frequently, provide you more access to ACT and the subject matter experts here, and maintain kind of the very quick turn budgetary and official quote turnarounds that we have maintained. But really, we know you guys are the experts in the field and are out there finding the opportunities. We want to make sure that we're not causing any bottleneck on the side. So you now have a larger sales force that are focused not only on HVAC but other ACT product lines. So there's a really strong thermal expertise, and then we're relying on you guys to provide that kind of HVAC business side expertise. So again, thank you for joining us. The first module we'll go through today is just a background to ACT and some of our other business models. We think this is somewhat important because we do have kind of a leg above the competition as far as overall thermal expertise. So we certainly want to promote that as much as possible. And then after that section, we'll get into the core products, and it's going to be very quick, basic training on the air-to-air and the wraparound heat exchanger, and then a run-through of the online tools that we provide. That is a really good way for you to get information to us and allow us to quickly turn quotes for you guys. So again, really appreciate you joining us today, and look forward to your feedback afterwards. Hopefully you get something good out of this, and feel free to reach out anytime. We really appreciate having you guys on board and look forward to growing the business with you. Thanks. So for the first module, we're just going to give a background on Advanced Cooling Technologies, kind of how we started, who we are, and some of the other product groups that you might not be fully aware of. So ACT is located in Lancaster, Pennsylvania. We were founded 15 years ago and started as kind of a research and development firm, primarily working on government, small business, innovative research programs. And from there, we've grown to currently 115 employees and have over 50,000 square feet here in Lancaster, PA, and are now a combination of product sales, technical services, and research and development. As a company, our core values are innovation, customer care, and teamwork, and hopefully we demonstrate that to our rep network as well, as we believe you guys are part of the team. And over the course of our 15 years, we've won several awards in the SBIR commercialization realm, the Tibbetts Award. We've been a 5-time winner of one of the fastest growing companies in central Pennsylvania, a 3-time winner of one of the 100 best places to work in Pennsylvania. And we've also been awarded a Outstanding Supplier Award from one of our aerospace prime contractors for some of our inaugural work on satellite CCHPs. So just to give you a sense of our other business units, the defense aerospace is one of our largest product sales as well as technical service areas. So ACT actually has products on everything you see here. We have over 25 million hours on orbit in space. We have heat pipes, phase change material, and other products on fighter jets and commercial aircraft. We have products on ground-based military as well as shipboard applications. And you can see some of the products there. These are kind of highly technical products. A lot of them are focused on heat pipe technology using the same principles that'll go into your system, but various working fluids based on temperatures and requirements. But we are kind of familiar with a lot of the very rugged, harsh environment applications and have products around those applications. The customs product group is kind of anything outside of the realm of defense, aerospace, and HVAC. And these are very diverse range of products. So we do heat pipes again, high temperature heat pipes, which you can see kind of the glowing red in the top middle there. We do pump two-phase, phase change material, so a very diverse product range and into kind of the high-end industrial markets. So we have products in a lot of power electronics cabinets, as well as one of our larger customers is GE, providing MRI equipment, MRI machines to the medical industry. So we do have a lot of experience in these type of high-end industrial applications as well. And now real quick, just to give you an overview of heat pipes, that is kind of our core product that we're selling into the HVAC market. So the big benefit of a heat pipe is that it is passive operation, so there's no moving parts, there's no power required to operate it. It gives you that really good heat transfer without that energy requirement. So the way it operates is it utilizes two-phase heat transfer. And so what will happen is on your hot air stream, the fluid inside will actually boil and create a vapor pressure inside, which will allow that fluid to move very rapidly to wherever it's colder in your system. And on the colder side, your cold air stream will actually condense the fluid back to a liquid, and it'll return back to the hot end either by gravity or an internal wick structure. In your systems, because of the length of the systems, it'll rely on gravity, so there'll be actually thermosiphons as opposed to heat pipes, but it still gets you that really efficient heat transfer and two-phase flow. So if there's any questions on heat pipes, this is kind of our core area of expertise, so feel free to reach out to us. We do, as I mentioned in some of the other product groups, we do a lot of various fluids, so although it's primarily refrigerants in the HVAC area, we have a lot of fielded heritage with water-based heat pipes. Our satellite product line goes with ammonia as the lower temperature working fluid. We also have high temperatures up to liquid metal temperatures. So we're very familiar with kind of the entire plethora of heat pipe technologies. And if you have any unique applications that might not use a refrigerant, we'd be happy to explore those as well. And that's one of the big differentiators with us and some of the other competition within this space. So yeah, let us know if you have any questions on heat pipes. From here, we'll go to some of the more specific product trainings.
Hi, I'm Kim Fixie, and a sales engineer here at ACT. Now we will discuss the ways in which a heat pipe is utilized in the HVAC industry. ACT has designed and manufactured two different types of heat pipe heat exchangers. The first we'll discuss is a wraparound heat pipe heat exchanger, which is used to enhance the dehumidification process. After, we'll discuss an air-to-air heat pipe heat exchanger. In a typical wraparound heat pipe heat exchanger, the hot, humid outside air hits the heat pipe pre-cool coil. In the pre-cool coil, heat is removed from the incoming air. After the air goes through the cooling coil, it goes through the reheat coil. In the reheat coil, heat is reintroduced to the air. This saves on the electricity cost. The cooling coil sees much lower temperature air than what is coming in from the outside, and therefore doesn't take as much energy to drop it to the dehumidification temperature. These wraparound heat pipe heat exchangers are able to provide pre-cooling of the incoming airstream, which increases the air handler's ability to remove moisture, or latent energy, by requiring less energy to do so. It's also able to accomplish this in the completely passive system by using those passive heat transfer systems, heat pipes. This saves on gas or other electricity and parasitic losses due to the energy cost. These systems also can be sized as large as coils can be built, which means that they can generally retrofit without any major ductwork changes. Because it is a passive system, it is very low maintenance. There are no moving parts, which means no plugging, no belts, no bearings. We also see a very small drop in static pressure. It's typically about 0.15 to 0.45 inches of water for a typical 2 to 6 row wraparound heat exchanger. In order to process this, or in order to get a quote from ACT, filling out the selection tool is the fastest way. When a correctly filled out selection tool is submitted to ACT, we can turn around a quote in less than 24 hours. At a minimum, we need the following information: the airflow rate, inlet temperature, so inlet temperature, inlet qualities are the dry bulb, wet bulb temperature, conditions after active cooling, dry bulb, wet bulb there, and the desired temperature of the air after the heat pipe reheat coil. Then also the parameters such as fin height, fin length, and the approximate air gap or gap between the pre-cool and reheat coils. Later on, I will go through the wraparound heat pipe selection tool to offer some more support. Now we will discuss the air-to-air heat pipe heat exchanger. An air-to-air heat pipe heat exchanger is typically used when your desired air temperature is different from the inlet air temperature. So say it's a cold day and your inside air temperature is 72 degrees Fahrenheit and your outside air temperature is 50 degrees Fahrenheit. You would use an air-to-air heat pipe heat exchanger to transfer some of that heat so you don't lose it on all your exhaust air, therefore reducing the amount of energy you have to put in to bring it up to your desired temperature. Now these air-to-air heat pipe heat exchangers can be sized to match all existing coils and can be installed in either a side-by-side or split duct. The benefit of that is, say your exhaust air is somewhere on the roof and then 30 feet away your inlet air. With a heat pipe or split loop heat pipe heat exchanger, you're able to still do the air-to-air system and still exchange in an efficient, effective manner. Also, because both of these are in separate ducts, you don't have any cross-contamination of airstreams. This is good when considering a hospital or even a nail salon where you want all of that air and all of the chemicals to be removed from the environment, but not remove all the temperature. They do meet ASHRAE standard 62-2010 for ventilation and acceptable indoor air quality. Much like the web-based selection tool for the wraparound heat exchanger, if a correctly completed selection tool is submitted to ACT, we can typically quote in less than 24 hours. Again, we do have a minimum amount of information needed in order to supply the quote. So supply airflow rate, return airflow rate, outside air conditions, the dry bulb, wet bulb temperature there, returning air conditions, so the dry bulb, wet bulb temperature there, desired supply air temperature and dry bulb temperature with that. And then the geometry, so the supply fin height, supply fin length, exhaust fin length, and then also do you need frost control? I will go in the next section to discuss more on the selection tool. We will now go over filling out the selection tool for the wraparound heat pipe heat exchanger. In order to get to the selection tool, you go to www.1-act/HVAC/WAHX. Scroll down to about halfway down the page. The first thing to click is this project information. Click that and start your design. So let's say we're doing a design for Orlando. Let's see. Oops, there it is. Orlando. By filling in the design city, what we get is the airport information and that bin data from the local airport of whatever city you choose, or whatever city is closest. Let's say we're going to do some sort of hotel. My name is Kim, work for ACT, email Kim 1-ACT. All right. So then I filled out all that information. Now I want to talk about my parameters. We're in Orlando, so let's say the incoming air is pretty hot. So the dry bulb temperature for the incoming air is going to be right around 105 degrees Fahrenheit. And my wet bulb temperature is going to be 80. It's pretty humid there. I want to do 52.5 for my cooling coil because that's what's going to be able to drop out the humidity. And then supply air, my hotel would love it if I could get it up to 70. So now that I have all that information in, and my airflow, I forgot to add my airflow. Let's go with 6,000 SCFM and the face velocity of 500 FPM. So now that we have all that in, let's start calculating. All right. So here we've got 3 rows, 10 fin per inch, and 9.4 tons of cooling capacity, and a pressure drop of 0.5 IWG. There are some ways to customize this. One way is to click on Rate. This means I can actually switch up how many rows and how many fin per inches, and then calculate again. This gives me a much higher pressure drop of 0.72 IWG. Other ways to customize is to change up your actual face velocity. So if I know my fin height is going to be 30 inches and my fin length is going to be 12 inches, my face velocity is too high, so I have to change the ratio in order to make it work. Let's go 30 and 30. All right, let's actually go 30, 24. Nope, that's too high too. 30 and 30. All right, now we'll compute this. All right, so we've got a pretty significant pressure drop here of 2.18. 10.2 tons of cooling and 122.7 megabtus per hour of reheat. That seems pretty high. Let's go back to the 500. We're just going to do face velocity. And then we're going to go to select. This way, it'll compute and select the best rate for us. Now, this is the calculation based on the best total pressure drop. You can continue to play around to try to get some better numbers as far as pricing go. Less rows, the lower price, and play around with what you believe the project's goals are. So now we have our system laid out and the numbers calculated. There's 2 options. We can either submit to ACT, which means our PDF and our selection will go directly to ACT's online email that will be reviewed by personnel internally at ACT. Or we can click the View PDF. View PDF essentially prints out a PDF for you right here. This PDF can then be used in your own records and then also submitted to ACT via your sales engineer or our sales assistants, whomever you have the best contact. Now, these selection tools don't have things like coatings, for example, hair site or electrofin coating, as well as different controls. We do coatings and controls. It's just a matter of letting us know. So if you fill out a selection tool and you would like some sort of temperature control, say a thermal passive valve or a control valve for one of your rows, we can certainly do that. Just let us know and we'll add that to our quoting system. Now let's look at the air-to-air heat pipe heat exchanger. So I'd already started filling this out. Much like the wraparound, you just go to www.one-act.com/HVAC/AAHX. Again, halfway down the page, you'll see this. Project information. So I started filling it out for Birmingham, Alabama. We're going to say it's a school. Once again, Kim, ACT, my email, kim.fixie@one-act.com. All right. So here, we're looking at all of our supply side information and our outside air and exhaust air information. So I know I have outside air This is Alabama. We're going to say it's about 90 degrees Fahrenheit with a wet bulb of 65. And I know that my desired temperature is really going to be right around 72. So my exhaust to return air is going to be 72. With a wet bulb of 62 works. And we'll go with the dry bulb supply air. I'd like it to be kind of closer to 80. So that way I don't have to take out too much heat. I'm taking out 8 degrees Fahrenheit of heat compared to the 90 degrees Fahrenheit here. And we'll keep the airflow at 400 SCFM for both the supply and return air. I'm okay with just keeping these dimensions as 30 inches and 40.5 inches, but this is where it really matters on your project for us to understand what your supply side and exhaust side sizing is. So now that I have all that figured out, and I can change galvanized steel, coating, I'm going to keep none, and frost control. We're not going to do frost control for now. So I'm going to compute. For this, I need 7 rows, 12 fins per inch, and this can handle 42.8 megabTUs per hour. In order to get my supply side at 80 degrees Fahrenheit. Again, this selection tool can be customized. You can click rate, we can drop it down. Let's do 4 rows and see what happens. 4 rows, we can't handle quite as much energy. And our dry bulb temperature did go up. It's now at 81.9. So if you're okay with that, with having less rows, then that works too. It's a matter of what the critical path is for your customer. If you don't know what the best changes are in order to meet the critical path, that's something to just call us about. So again, here you can submit to ACT or view the PDF. If we view the PDF, it's another one that you can keep for your records and then submit and send to your corresponding sales engineer. Take a look at this. Again, with air-to-air heat pipe heat exchangers, we can do controls and we can do coating. For this one, you can pick your coating option. There are other coatings available. Like I said, Harrisite coating is an option as well. Just let us know what your criteria is and we can customize it for your needs. And if you have any questions on the heat pipe selection tool, feel free to reach out to myself or Brian or Devin, and we would love to be able to sort you through and help you understand it. Thanks, and we'll continue with the discussion.
Hello again, this is Brian. Hope everyone had a good time going through the product training as well as the intro to the selection tool. Hope everyone's comfortable using those tools going forward. The final couple items we'll go through is just an introduction to the sales team and then a quick facility tour and flow through the process one more time. And just to give you some background on kind of ACT's sales team, we like to promote very technically capable people to be your primary resource. So all of our territory-based managers do have a degree in engineering, and kind of with that, we'll jump into it and go from kind of the eastern side to the western side and give you a quick background into all your primary points of contact, and hopefully you'll get to know them a lot further as you start beginning your working relationship with them. So on the east, which spans from New England down to the Carolinas, Dennis Pamuchu is the territory lead. Dennis has been with ACT since 2014. He holds a bachelor's in chemical engineering and business management from Lehigh University and got his master's in technical entrepreneurship from Lehigh University as well. In addition, in the east, because there's a lot of demand in our other markets, we also have an inside sales. Heidi Hansen supports Dennis in the East area as well. So she's a nice resource there for anyone if you're having trouble getting a hold of Dennis. Kim Fixie is our sales engineer for kind of the central area. So her territory ranges from Michigan down to Florida and then across to Texas. You can see the states highlighted there. Kim has been with ACT since April of 2015, and she holds a bachelor's in energy engineering from Penn State University. Myself, I handle kind of the Midwest and mountain states as well as Canada. My background's in mechanical engineering. I also graduated from Penn State for my bachelor's and got my MBA and engineering degree from Lehigh. Seth Ryberg is our newest member of ACT. He's been with us a little over a year, and he has responsibility for Northwest states as well as Southern California. Seth graduated with a mechanical engineering degree, also from Penn State University. And finally, Pete Ritt, who heads the sales and marketing department, has just a small territory-based responsibility in Northern California, Nevada, as well as Arizona, New Mexico, and a portion of Western Texas. Pete's background is in chemical engineering from Notre Dame, as well as an MBA from Shippensburg, and he has 30-plus years experience in the industry and a great resource for anything sales and marketing related. And the final person that you'll probably see copied on most of the correspondence is Brittany Heschley. She is our inside sales representative, and she kind of handles most of everything for the HVAC world. So she coordinates our travel, makes sure that quotes get out in a timely fashion. She can provide you marketing collateral as you need it, so feel free to request that from Brittany. When sales engineers are out of the office, either on business travel or vacation, and might have some delays in getting back to you, she'll be your primary point of contact and will coordinate with you and the engineering team. And she also serves as our CRM administrator. So just one final rundown of the process for new inquiries. We strongly encourage you get on the selection tool and submit that way. That really helps us out in getting you an extremely quick turnaround on a quote. If you don't have access to that or need to email a request in, there's something unique about it. We'd recommend that you include kind of all the members we mentioned. So your sales contact based on the territory, Brittany, as well as Devin from the engineering side. That way, if anyone's out of the office, we'll make sure to get you something back very quickly. So it's always our goal to get you a 24-hour turnaround on a quote, and at least communicate that we got it and iterate with you on design parameters if there needs to be some technical review involved. So with that, we'll kind of transition to the final segment, which is a facility tour. And just wanted to, again, thank everyone for joining us. Hope you learned something, and feel free to reach out to your territory contact if there's any further questions, if you need anything else from ACT, and we look forward to growing the HVAC side of our business with you. Thanks.
Welcome to Advanced Cooling Technologies. We provide solutions to our customers' diverse thermal problems. We'd like to give you a quick behind-the-scenes tour of our HVAC division. I'm Devin Pelicone, the lead engineer of ACT's Custom Products Division, and will normally be your first point of contact. I will assess your initial information and may reach out to you in order to clarify design requirements to ensure proper sizing of our products. I work with your point of contact on the sales team to return a quote in a timely manner. Once you place an order, John Brubaker manages the order through manufacturing and shipment. John takes the job specifications and provides shop drawings for your review. Once the drawings are approved, the manufacturing timeline begins. As the parts arrive, they are inspected to ensure they meet all of your specifications. The heat exchanger is then assembled in our shop, with a stop at the coaters if required by the project. Once the heat exchanger is complete, a thermal test is performed in order to confirm proper operation. ACT occupies more than 50,000 square feet in the Burrell Business Park in Lancaster, Pennsylvania. While this is adequate for most HVAC orders, during unusually large orders we are able to utilize additional space inside of the business park. ACT employs over 100 people, and resources are shifted to provide timely delivery on any size order. Lead time is typically 6 weeks for most orders, with an additional 2 weeks for jobs that require coding. We hope you enjoyed this quick tour. We look forward to working with you soon and hope we have demonstrated how we can add value to your project.